Welcome to the Sleepy Science. I'm delighted that you've found your way here, whether you've had a long, tiring day, or you're the kind of person who finds solace in drifting off to sleep while exploring the depths of cosmic mysteries. Regardless, this journey is tailored just for you. Tonight, you have nothing to do but rest. Allow your mind to unwind, your breathing to slow, and your body to feel as if gravity itself has softened its grip. For tonight, we're not simply gazing at the stars. We're embarking on a voyage through our home galaxy, the Milky Way, a vast, spiraling expanse of stars, dust, and dark matter that has been turning slowly in space for over 13 billion years. But beneath its captivating beauty lies a world of secrets waiting to be uncovered. Rogue stars, invisible forces, and ancient remnants that defy our understanding. These are the mysteries we'll explore, traveling gently from the spiral arms to the hidden core, from colossal collisions to stars older than the galaxy itself. You'll hear tales of black holes and stellar nurseries, and the strange, unfinished story of a galaxy that continues to evolve and grow. Some of what you hear may surprise you, or at the very least, spark a sense of curiosity as you drift off to sleep. And before we begin, I'd like to invite you to consider liking and subscribing to the channel. If these calm, curious explorations have helped you unwind or provided a peaceful way to end your day, it would be a great help in allowing others to find their way here as well, one sleepy soul at a time. Now, let us embark on this journey together. The Milky Way, our celestial home, has a dynamic and ever-evolving history. It is not a static, isolated entity, but rather a galaxy that has collided with and absorbed smaller galaxies over the course of billions of years. These mergers have left their mark with tidal streams of stars wrapping around the galactic disk, remnants of the galaxies that have been drawn in and unraveled. Even now, we can witness the Sagittarius dwarf galaxy being pulled apart, its stars scattered into the Milky Way's embrace. And in the distant future, an even more dramatic event awaits. Andromeda, the great spiral galaxy, is drifting ever closer to us. And in approximately 4.5 billion years, the two giants will collide in a cosmic dance. While the individual stars may rarely, if ever, collide, the shapes of these galaxies will be forever transformed, folding into a new, vast, and serene form. Yet, the Milky Way itself is not eternal. Galaxies, like all celestial bodies, are subject to the relentless march of time. They evolve, they collide, and they are reborn, each chapter in their story a testament to the dynamic and ever-changing nature of the universe. Even the stars that make up our galaxy are not all native to this place. Some of the oldest stars, the halo stars, appear to have originated in smaller primordial galaxies that merged with the Milky Way long ago. These ancient metal-poor wanderers, moving in long tilted orbits high above the galactic plane, are like elder spirits from a time before the Milky Way took its familiar spiral form. In their light, we glimpse a universe that was younger, wilder, and still in the process of becoming what it is today. Our own solar system, a mere speck in the grand scheme of the Milky Way, orbits the galactic center at a dizzying speed of over 828,000 kilometers per hour. Yet, it takes approximately 225 million years to complete just one revolution around the galaxy, a galactic year. In the time since the solar system formed, we have circled the Milky Way a mere 20 times. When the first dinosaurs roamed the Earth, we were in a different part of the galaxy entirely. The stars we see today will not always remain in their current positions, for everything in the cosmos is in constant motion. Even as we sleep, the Earth turns, the moon circles, and the entire solar system sweeps forward through the ever-changing tapestry of the Milky Way. This galaxy, our home, is a dynamic and ever-evolving entity, a testament to the ceaseless motion and transformation that permeates the universe. The Milky Way, our majestic galactic home, is a work in progress, ever evolving and expanding. Though ancient, it is far from finished as it continues to gather material from its surroundings. Gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter all contribute to the Milky Way's ongoing growth. This growth is not like that of a living organism, but rather a deepening of its gravitational structure over time. Some of this growth happens quietly, as clouds of gas and dust fill in the gaps. Other times, it comes with disruption as satellite galaxies are torn apart, their stars scattered across the celestial canvas. The galaxy you and I inhabit today is not the same one that the dinosaurs witnessed millions of years ago. And the Milky Way that our distant descendants may one day know could be even larger, stitched together from the ruins of 1,000 smaller worlds. One of the enduring mysteries about our galaxy is the number of spiral arms that emanate from its center. It's a question that seems like it should have a simple answer. Yet from our vantage point deep within the galactic disk, it's surprisingly difficult to discern. Dust clouds obscure distant regions, and stars blur together, making it challenging to map the Milky Way's full structure. For decades, astronomers believed there were 4 major spiral arms. More recent observations, however, have suggested a more complex picture, with the arms twisting, splitting, and fading into fragments in ways that defy our expectations. Some arms may wrap around the galaxy in unexpected patterns, defying the neat pinwheel shape we once envisioned. The Milky Way, it seems, is not a static, orderly structure, but a living, layered swirl of stars shaped by forces that we still don't fully understand. It is a dynamic, ever-changing entity, a testament to the ceaseless evolution and growth that permeates the cosmos. As we gaze upon its splendor, we are reminded that the galaxy we call home is a work in progress, a canvas upon which the story of the universe continues to unfold. The Milky Way, our majestic galactic home, is not just a serene tapestry of stars. Amidst the tranquil drifting of most celestial bodies, there are rare and remarkable outliers, the rogue stars, flung from the core at astonishing speeds. These hypervelocity stars, some of which are the remnants of binary systems disrupted by the supermassive black hole at the galaxy's center, are hurled into the void at over 1 million kilometers per hour. Alone and far from the galactic plane, they streak through the darkness like glowing comets, a testament to the moments of violent release that can occur even in a galaxy bound by the gentle pull of gravity. But the Milky Way story is not one of chaos alone. High above the horizon, we can glimpse the faint blur of another great spiral, the Andromeda Galaxy lying over 2 million light-years away. And yet, this distant companion is steadily moving closer to us. In approximately 4.5 billion years, the Milky Way and Andromeda will collide. But this will not be a cataclysmic event, as the stars are spaced too far apart to crash directly. Instead, the 2 galaxies will engage in a slow, elegant dance, their gravity warping them into long, stretching arcs, their tidal tails curling outward, their black holes perhaps spiraling together. After billions of years, the 2 will merge into a single larger system, a testament to the cosmic choreography that shapes the future of our celestial home. Even the orderly motion of the stars within the Milky Way holds hidden stories. Most orbit the galactic center in the same general direction, but a select few, particularly in the outer halo, move in the opposite, retrograde direction. These stars likely arrived from elsewhere, born in dwarf galaxies that were later absorbed by our own. Their reversed motion is a quiet signature of their foreign origin, a reminder that the Milky Way carries within it the memories of ancient mergers and cosmic encounters, preserved not in light, but in the slow, patient turning of the stars against the stream. The Milky Way, our ever-evolving, ever-changing galaxy, is a tapestry of both tranquility and turmoil, a canvas upon which the grand drama of the universe unfolds. From the rogue stars flung into the void to the collision course with Andromeda, the Milky Way story is one of constant motion, a testament to the dynamic and ever-shifting nature of the cosmos. The Milky Way, our majestic galactic home, has not grown alone over the course of billions of years. Rather, it has been a voracious consumer, steadily absorbing smaller, faint luminous companions, dwarf galaxies that have drifted too close and been caught in its gravitational embrace. These smaller worlds have been slowly dismantled, their stars now woven into the fabric of our own galaxy's halo, disk, and stellar streams. Astronomers have identified several of these ancient mergers by carefully analyzing the motion and chemical composition of the stars within the Milky Way. One particularly significant event, the Gaia-Enceladus merger, is believed to have added a substantial number of stars and may have even reshaped the early structure of our galaxy. The Milky Way, then, is not a pristine spiral, but rather a composite, stitched together from the remains of many smaller worlds, a tapestry of quiet collisions and cosmic consumption. The chemical fingerprints of stars hold the key to unraveling this hidden history. Each star carries a unique pattern of elements imprinted at the moment of its birth. By studying these signatures, astronomers can trace a star's origins and group them into families, revealing the ancient mergers and migrations that have shaped the Milky Way over time. Some stars are rich in heavy elements like iron and calcium, suggesting they formed in dense, metal-rich regions. Others are nearly pure hydrogen and helium, remnants of a time when the universe was still young and the Milky Way was in its formative stages. These differences in stellar chemistry act as a kind of time machine, allowing us to read the past like a line of ancient poetry written in the light of the stars. The Milky Way, then, is not a solitary, isolated entity, but rather a dynamic and ever-evolving galactic tapestry woven from the remains of countless smaller worlds that have been consumed and integrated over the course of its long history. Its story is one of quiet collisions, cosmic consumption, and the chemical signatures that reveal the hidden narratives of its past. The celestial canvas above us is a tapestry woven with the remnants of shredded galaxies. Across the sky, thin ribbons of stars stretch in graceful arcs and curves, barely visible to the naked eye, but unmistakable when mapped with precision. These are the stellar streams, the ghostly traces of smaller galaxies that wandered too close to the Milky Way and were torn apart by its immense gravitational pull. As these former companions orbit the Milky Way, their stars are smeared across space by tidal forces, forming long, delicate trails that trace the paths of their former hosts. Some of these streams wrap around our galaxy like ethereal halos, while others dive inward toward the galactic core. These stellar streams are the evidence of past collisions, the quiet mergers that have built the Milky Way over the course of billions of years. Like the rings of a tree, our galaxy carries the imprint of its tumultuous history in every thread of starlight. But the Milky Way story is not one of a static, perfect spiral. Our galactic home does not lie flat, but rather bends and waves, its disk curving upward on one side and downward on the other, forming a graceful undulation across the stars. This subtle warp was invisible to us until radio telescopes mapped the hydrogen gas that extends far beyond the visible starlight. Astronomers believe this distortion may be caused by the gentle tugging of satellite galaxies on the Milky Way's edges, or by the influence of clumps of dark matter bending the structure from below. Like ripples in a great spinning sheet, the Milky Way's warp reveals that even galaxies are never truly still. Over time, they bend, flex, and change form in response to the invisible forces that shape the cosmos. From a distance, our galaxy might appear to be dancing slowly through the void, its elegant curves and waves a testament to the dynamic and ever-evolving nature of the universe. The grandeur of the Milky Way stretches far beyond the limits of human vision. Under the clearest, darkest skies, we may behold a few thousand stars, an ocean of light that seems boundless to our eyes. Yet this is but a minuscule fraction of the true vastness of our galactic home, which contains over 100 billion celestial bodies. The majority of these stars remain hidden from our view, obscured by thick veils of cosmic dust or simply too faint and distant for our eyes to perceive. The pale, luminous band that arches across the night sky is but a whisper of the Milky Way's true splendor, a colossal river of starlight that surrounds us, yet remains largely invisible, too vast for us to fully comprehend from within. Unlike the orderly orbits of planets around a single star, the stars that make up the Milky Way move with a greater degree of freedom. Some race ahead in the inner regions, while others drift more slowly along the galactic outskirts. This difference in stellar motion is the driving force behind the formation of the Milky Way's iconic spiral arms. Not solid structures, but rather patterns akin to slow-moving traffic jams of stars and gas, triggering the birth of new celestial bodies as they pass. Our own sun is part of this cosmic swirl, moving in and out of these spiral patterns over time. The Milky Way is not a clock, but a current in which we are adrift, carried along by the ebb and flow of its celestial currents. And yet, the very existence of the Milky Way defies logic. By all measures, the stars, dust, and gas at the galaxy's outer edges should be flung into the void, scattered like leaves in a storm. But they remain, held in place by a mysterious, invisible force, dark matter. This enigmatic substance, which does not shine, reflect, or emit any light, exerts a powerful gravitational pull, outweighing all the visible matter in the Milky Way many times over. Without this invisible scaffolding, our galaxy would fly apart, its components cast into the intergalactic void. Dark matter is the unseen foundation that holds the Milky Way together, a testament to the hidden forces that shape the cosmos. At the very core of our Milky Way galaxy lies an extraordinary celestial entity, a supermassive black hole known as Sagittarius A. This cosmic behemoth is more than 4 million times the mass of our Sun, yet it occupies a space smaller than the orbit of Mercury. Though we cannot see it directly, we have observed the telltale signs of its immense gravitational pull, watching as nearby stars whip around it at tremendous speeds, tracing invisible loops through the void. Occasionally, gas and dust fall inward, spiraling into the black hole's event horizon and flaring with X-rays as they do so. For now, Sagittarius A slumbers, but in the distant past it may have burned brightly as a quasar, lighting up the galaxy from within. This silent conductor of the Milky Way's heart continues to pull the stars into a slow, relentless dance, its gravity shaping the very fabric of our galactic home. When astronomers mapped the center of the Milky Way, they uncovered an unexpected revelation. The central bulge is not a smooth, round ball of stars, but rather a three-dimensional peanut shape. Seen from the side, it swells in the middle and narrows at the ends, like a twisting hourglass made of stars. This strange geometry is likely the result of the galaxy's central bar, a dense stripe of stars that rotate slowly, buckling and puffing upward over the course of billions of years. These intricate inner structures are sculpted by the relentless forces of gravity, the accumulated rhythm of stellar orbits, and the endless motion that defines the Milky Way. Though we live in a spiral galaxy, its heart is far from simple or flat. Instead, it is a realm of complexity, a tapestry of interwoven patterns and shapes that defy our expectations, a testament to the dynamic and ever-evolving nature of our celestial abode. The Milky Way's majestic spiral arms are not merely composed of stars, but rather woven from the very birthplaces of those celestial bodies. Giant clouds of hydrogen, dust, and molecules drift through the galaxy, and as they pass through the spiral arms, they are compressed and ignited, giving rise to newborn suns. These regions, known as stellar nurseries, are chaotic, glowing, and teeming with motion. The ultraviolet light from these young stars illuminates the surrounding clouds, painting the arms with radiant blues and silvers. These bursts of creation trace out the spiral shape, igniting the curves of the galaxy with a quiet, persistent fire. Every star in the Milky Way, including our own sun, was born from one of these cloudy cradles long ago. But the Milky Way story extends far beyond its luminous spiral disk. Surrounding the galaxy is a vast, diffuse halo, a spherical expanse that contains ancient stars, globular clusters, and enormous quantities of dark matter. Though nearly invisible, this halo may hold the majority of the Milky Way's mass. Its stars are spread thin across immense distances, orbiting in long, slow arcs that rarely intersect with the galactic disk. The halo also preserves the remnants of ancient galactic mergers, streams and shells of stars torn from smaller galaxies and left behind like cosmic fossils. It is the Milky Way's outer memory, quiet and dim, yet still in motion, still shaping the galaxy's ongoing evolution. Within this halo, the Milky Way harbors over 150 globular clusters, compact spheres of hundreds of thousands of tightly bound stars. These ancient objects, some more than 12 billion years old, orbit the galactic center like moths, circling a distant flame. Many of their stars predate the Milky Way itself, having formed before the universe had time to create the heavier elements. These globular clusters serve as time capsules, holding clues to the Milky Way's formation, the galaxies it has consumed, and the conditions of the early cosmos. Like quiet, golden spheres, they drift patiently above and below the galactic plane, glowing in the dark, guardians of the galaxy's most ancient secrets. The ever-evolving dance of the cosmos. It seems the Milky Way, our galactic home, is settling into a more serene rhythm, its once frenetic star birthing pace slowing down over the eons. But make no mistake, our galaxy is far from done with its stellar production. It's simply entering a more mature phase, a gentle glow in the cosmic middle age. In the distant past, the Milky Way was a veritable nursery, bursting with newborn stars, forged from dense, collapsing clouds of gas. But as time has marched on, much of that fuel has become spread thin, heated, or locked in forms that resist collapse. The galaxy's star-making machinery is still running, but it's no longer operating at full tilt. Interestingly, some of the stars within our galactic abode predate even the formation of the Milky Way's iconic disk. These ancient celestial elders, residing primarily in the halo or thick disk, were born when the galaxy was still a loose assemblage of stars, gas, and dark matter, slowly coalescing into the spiraling structure we recognize today. By studying these stellar fossils, astronomers can peer back into the eras before the Milky Way took on its familiar form, witnessing the long, gradual shaping of our cosmic home. And let's not forget the grand scale of galactic time. A galactic year. The time it takes for our sun to complete one full orbit around the Milky Way center spans a staggering 225 to 250 million Earth years. In the time it takes for our star to circle the galaxy once, entire continents have drifted, species have risen and fallen, and whole epochs have unfolded. We are but a fleeting blink in the cosmic clock, yet we are privileged to witness the Milky Way's ever-evolving story. The cosmic dance of our sun, a mere newcomer in the grand scheme of the Milky Way. Despite its incredible speed, zipping around at nearly 830,000 kilometers per hour, our star has only completed a little over 20 orbits of our galactic home in its 4.6 billion years of existence. The vastness of the Milky Way and the sheer length of our sun's path are truly humbling. Each galactic revolution takes hundreds of millions of years to complete. We often think of the stars as ancient and unchanging, but our solar system is still a relative youth in the galactic city, surrounded by older, more well-traveled celestial bodies. We may be part of the Milky Way's grand motion, but we are still early in the unfolding of its long, winding story. And the Milky Way itself defies our classical expectations. According to Newtonian physics, the stars farther from the galactic center should orbit more slowly, just as the outer planets in our solar system move more leisurely around the sun. Yet, in our galaxy, the stars in the outer regions zip around almost as quickly as those near the center. What could be the reason for this perplexing behavior? Astronomers believe the answer lies in the mysterious realm of dark matter, an invisible, unknown form of mass that surrounds the Milky Way in a vast, unseen halo. Without this dark matter, the galaxy would not be able to hold itself together. But with it, the math aligns and the Milky Way turns like a solid wheel, not because we fully understand it, but because something unseen is keeping it in place. And scattered throughout this galactic wonder are the enormous dark clouds of cold gas, the raw material from which new stars and planets are born. These molecular clouds, composed primarily of hydrogen and dust, can span hundreds of light years across. Within their frigid, dense interiors, gravity gathers material, forming clumps that collapse into the celestial bodies of the future. Some of these clouds are so large and so cold that they absorb all visible light, appearing as black patches against the starry backdrop. They are the Milky Way's wombs, quiet, hidden places where the future begins in silence, shrouded in the curtains of shadow and gas. The Milky Way, our galactic home, is a dynamic and ever-evolving canvas, where the dance of creation and destruction plays out in a grand cosmic symphony. At the heart of this celestial ballet are the cataclysmic events known as supernovae, the explosive demise of massive stars that can outshine entire galaxies for a fleeting moment. These violent outbursts are not merely the end of a star's life. They are the harbingers of new beginnings. The shockwaves from these supernova explosions ripple through the interstellar medium, compressing nearby clouds of gas and dust, triggering the birth of a new generation of stars. And in the process, they enrich the surrounding space with the heavy elements forged in the heart of the dying star, like iron and gold, seeding the galaxy with the building blocks of future worlds. In this way, supernovae act as the storms within the galactic ecosystem, stirring, fertilizing, and reshaping everything around them. They are the moments of chaos, destructive and radiant, yet utterly necessary for the continued evolution and rejuvenation of the Milky Way. But the galaxy's secrets are not always laid bare for us to see. Shrouding vast regions of star formation are the tendrils and clouds of interstellar dust woven throughout the Milky Way like a cosmic veil. In visible light, this dust obscures stars and entire nebulae, creating the illusion of darkness and emptiness. Yet behind this veil, the process of stellar birth continues unabated. Infrared telescopes can peer through the dusty curtain, revealing the glittering nurseries where newborn suns are taking shape. What appears as mere darkness is often the cradle of future brilliance, for the dust itself is an integral part of the star-forming process, absorbing energy, helping gas cool, and shielding the delicate stages of a star's inception. And even beyond the regions of active star formation, the Milky Way holds its breath, as it were, in the form of massive cold clouds of gas that remain stubbornly starless. These dormant, untouched reservoirs of molecular hydrogen drift through the galaxy like silent possibilities waiting to be ignited. Some may one day collapse under their own gravity, sparking new stellar life, while others may be torn apart by external forces, their gas recycled into other regions of the galaxy. In these starless clouds, the Milky Way holds its breath, perhaps waiting for the right cosmic nudge to set the stage for a new chapter of creation and transformation. A testament to the ever-evolving, ever-renewing nature of our galactic home. Stars, those luminous beacons in the cosmic tapestry, are not permanent fixtures. They live, burn, and ultimately, they die. But in their demise, they return their material to the galaxy, fueling the next cycle of creation. Supernovae, those cataclysmic explosions, spread the heavy elements forged in the heart of dying stars. Red giants shed their outer layers, while planetary nebulae drift outward into the interstellar medium. This enriched material then cools, condenses, and eventually forms new stars, planets, and even the very building blocks of life. Every atom that makes up your being has passed through this endless cycle of birth, death, and rebirth. A testament to the Milky Way's role as a great engine of renewal. The galaxy breathes in time with its stars, making, unmaking, and beginning anew. A perpetual dance of creation and destruction that shapes the cosmic landscape. And within this ever-evolving tapestry, there are celestial fossils that hold the secrets of the early universe. These are the metal poor stars, found in the halo of the Milky Way, that preserve the chemical conditions of a time long gone. In astronomy, metals refer to any elements heavier than helium, and the earliest stars in the universe had almost none of these, as they formed before earlier generations had a chance to forge and scatter them. By studying the composition of these faint ancient stars, astronomers can peer into the primordial past, into the period just after the Big Bang, before galaxies had fully matured, and before the Milky Way itself had taken on its familiar form. These stellar fossils, made of light, offer a glimpse into the formative years of our cosmic home. And the Milky Way is anything but a static stage. Even the stars themselves do not always remain where they were born. Over time, many drift away from their natal clouds, pushed by gravitational interactions, orbital resonance, or the slow pull of the galaxy's spiral arms. Some are even ejected at high speeds, flung across the disk or into the halo, while others migrate gradually, shifting their orbits inward or outward as they spiral through the galaxy. Even our own sun is not where it began, its path a testament to the Milky Way's constant state of flux, a galaxy alive with movement, exchange, and quiet dislocation. For a star, its home may only be temporary, as it is swept up in the ever-changing currents of the cosmic ocean. The Milky Way, our cosmic home, may harbor a vast and wondrous habitable zone, much like the Goldilocks zone that allows life to thrive on Earth. This galactic habitable region is thought to lie between the perilous inner core, where radiation and gravitational chaos reign supreme, and the sparse, metal-poor outer edges, where planet formation may be more challenging. Somewhere in the middle, there exists a wide band where the conditions are just right, stable, with a moderate density of stars and an abundance of the essential elements for life, such as carbon, oxygen, and iron. It is within this zone that our own planet Earth orbits in quiet solitude, a single quiet orbit in the vast swirl of the Milky Way, where life may not be alone in finding a foothold. But the Milky Way's iconic spiral arms are not fixed structures, carved in stone. Rather, they are patterns, density waves that ripple slowly through the galactic disk, compressing gas and triggering the birth of new stars as they pass. The stars themselves do not remain permanently within these arms. They drift in, shine for a time, and then drift out again. The spiral structure moves at a different pace than the stars, like a traffic jam flowing through a highway. From a distance, it appears as a grand ordered design, but from within, it is a pattern of shifting motion, held together by the relentless pull of gravity and the march of time. The Milky Way's spiral arms are never still, always flowing, a dynamic dance of celestial bodies. And beyond the visible spectrum, the galaxy hums with a symphony of cosmic radiation. Cosmic rays, high energy particles born in the cauldrons of supernova and distant galaxies, stream through space, passing through our very bodies every second. X-rays and gamma rays shimmer from the final throes of dying stars and the voracious maws of black holes. Radio waves drift from the cold, dense clouds of gas, the pulsing beacons of pulsars, and the faint breath of hydrogen. These invisible hums reveal the hidden depths of the Milky Way, the violence, magnetism, and ancient fires still flickering within its celestial bones. When we gaze up at the night sky, we are only witnessing a narrow band of the galaxy's true spectrum. Beneath the stars, the Milky Way sings softly in a multitude of colors and frequencies, a hidden symphony in the dark. Towering high above and plunging deep below the Milky Way's core are two vast ghostly lobes of high energy light, the Fermi bubbles, a recent cosmic discovery. These enormous structures, stretching tens of thousands of light years, glow in the invisible spectrum of gamma rays, like twin balloons drifting silently over our galactic home. The origins of these mysterious Fermi bubbles remain uncertain. They may be the remnants of a long-ago outburst from the supermassive black hole at the Milky Way's heart, or perhaps the mark of fierce star formation that once flared through the galactic core. Regardless of their cause, these radiant structures serve as a reminder that our galaxy harbors a past we cannot fully see, echoes of violence and power, wrapped in an otherworldly luminescence, far above the familiar stars we gaze upon. While the Milky Way's grand spiral arms may seem like the main stage of galactic drama, our own solar system resides in a more modest setting. The Orion Spur, a relatively quiet lane of stars nestled between the larger Sagittarius and Perseus arms. This calm, unassuming region may have provided the ideal conditions for life on Earth to emerge and evolve, as the frequency of cataclysmic events like massive supernovae and intense radiation storms is lower here than in the bustling galactic highways. From the outskirts, the Milky Way may appear dramatic and radiant, but in this peaceful spur, we have found just enough tranquility for the complexity of life to unfold. And at the very heart of our galaxy, a remarkable structure takes shape, a bar-like formation of stars crossing the center, visible in infrared light. This elongated, glowing bridge rotates slowly, its gravitational pull shaping the inner spiral arms of the Milky Way. Bars like this are a common feature in spiral galaxies, formed as stars in the disk begin to drift inward and accumulate along a central axis. Over time, the bar becomes a stable dynamic engine, stirring up gas, triggering new star formation, and funneling material toward the supermassive black hole at the galactic core. It is not merely a shape, but a powerful force that sculpts the very heart of the Milky Way from within. The Milky Way is not an isolated entity, but rather a member of a larger cosmic family. The local group, a collection of more than 50 galaxies drifting together through the vast expanse of space. The two dominant members of this group are the Milky Way and its neighbor, Andromeda, each with their own retinue of satellite galaxies. Scattered around these giants are smaller, fainter dwarf galaxies, ellipticals, and even star-poor galaxies composed almost entirely of mysterious dark matter. Spanning more than 10 million light-years, the local group is bound together not just by proximity, but by the invisible threads of shared motion and mutual gravitational pull. Despite their vast separations, the galaxies within this family are not drifting apart, but rather moving slowly toward one another, caught in a kind of cosmic ballet, their paths curved by the relentless tug of gravity over millions of years. Some of the smaller galaxies even orbit the Milky Way like moons, looping and falling, eventually dissolving into stellar streams. Others drift independently yet remain tethered, caught in the web of shared motion that holds this family of cosmic islands together. Over time, this group may continue to condense, with galaxies merging, fading, or being absorbed, a gentle gathering of celestial bodies, drawn closer by the march of time, the inertia of motion, and the long reach of gravity. Turning our gaze inward, we find that the Milky Way's disk is not a uniform structure, but rather a layered, textured landscape. The thin disk, where we reside, is a wide, dense plain filled with young stars, open clusters, and star-forming gas. But above and below this thin disk lies the thick disk, older, puffier, and more diffuse. The stars in the thick disk tend to be older, with fewer heavy elements, and they move in orbits that are more tilted and elliptical, suggesting they formed under different conditions or were stirred by early galactic collisions. The Milky Way's disk is not a simple, flat expanse, but a complex, stratified realm shaped by the passage of time, like sediment settled on the floor of a cosmic ocean. And yet, even beyond the visible spectrum, the Milky Way breathes with a subtle, unseen pulse. The vast magnetic field that threads through its disk rises into the halo and weaves through the interstellar medium. Though weak by earthly standards, this galactic magnetic field plays a crucial role, shaping the paths of cosmic rays, the collapse of gas clouds, and the flow of matter through space. Aligning with the spiral arms, forming arcs above the plane, and twisting into loops that defy simple explanation, the Milky Way's magnetic field requires radio telescopes and careful analysis to unravel its mysteries. But its presence is undeniable. The galaxy does not just glow with light, but it also pulses with the subtle magnetism that runs through its very bones. The space between the stars in the Milky Way is far from empty. It is a realm teeming with invisible structures and unseen activity. The interstellar medium, a thin blend of gas, dust, and plasma, weaves its way through our galactic home like a cosmic fog, revealing its stunning complexity only when viewed through the lenses of radio and infrared telescopes. Within this unseen realm, the interstellar medium forms intricate filaments, bubbles, shock waves, and cold, dense clouds, the very nurseries where new stars are born. Supernovae carve vast cavities in this ethereal fabric, while stellar winds sculpt it into shapes that ripple across light years. The space between the stars is not a void, but a shifting web of matter and magnetism, the quiet foundation from which galaxies evolve and life eventually takes root. And coursing through this interstellar tapestry are the high-energy particles we call cosmic rays. Every second, these protons and atomic nuclei, launched long ago by the cataclysmic explosions of dying stars, stream through your very body, traveling at near light speeds, bending through magnetic fields, and occasionally colliding with atoms in Earth's atmosphere, creating showers of secondary particles. Most of the time, we remain oblivious to these cosmic messengers, but they carry stories from across the galaxy, evidence of ancient supernovae, traces of distant acceleration, and whispers from the violent hearts of stars. Even as you rest, the Milky Way is whispering in particles, in silence, in lightless rays. And the Milky Way itself is not a perfectly symmetrical, neatly ordered spiral as often depicted. One side of the galactic disk appears thicker. Some spiral arms are brighter, longer or more curved than others, and the warp in the outer disk is lopsided. Even the star counts between hemispheres are slightly off. These asymmetries may be the result of past gravitational encounters, mergers, or the influence of dark matter, reminders that galaxies, like living things, carry the scars and wrinkles of their histories in their very shapes. They are not pristine, perfectly balanced structures, but rather cosmic entities with character and depth, shaped by the ebb and flow of time, the collisions of the past, and the quirks of uneven growth. High above the Milky Way's galactic plane, drifting through the halo, astronomers have discovered a celestial treasure, a star that may be nearly as old as the universe itself. This ancient stellar relic, containing almost no heavy elements, is a living testament to the cosmos's earliest days, born long before generations of supernovae had a chance to enrich the galaxy. Likely formed over 13 billion years ago, this star predates the full formation of the Milky Way, and it now burns quietly with a soft, red glow, low in mass but rich in history. It is not merely a star, but a time capsule, a living relic from the dawn of the universe, a window into the primordial past. And within the Milky Way's inner regions, the dance of stellar motion follows a different rhythm. Here, near the galactic core, the gravitational pull is far stronger, packed with the mass of stars, dust, and the supermassive black hole known as Sagittarius A*. This intense gravitational field causes the stars to sweep through tighter, faster orbits, completing revolutions in just a few million years. In contrast, out in the galactic suburbs, where our sun resides, the stars orbit much more slowly, taking hundreds of millions of years to complete their celestial circuits. This uneven rotation creates twisting patterns, stretches the spiral arms, and prevents the disk from behaving like a solid, rigid structure. The Milky Way moves like a great wheel, but one whose rim lags behind the rapid spin of its core. And the iconic spiral arms themselves are not fixed trails of stars, but rather patterns formed by waves of higher density moving through the galactic disk. As gas and dust pass through these density waves, they are compressed, triggering bursts of star formation and lighting up the arms with bright young suns. Yet, these stars eventually drift out of the wave while new ones form behind them, creating a self-sustaining illusion of structure. Like ripples in a pond or traffic jams on a highway, the Milky Way's spiral arms are dynamic, always in motion. From a distance, they appear static and serene, but from within, they are a dance of matter and rhythm, shaped by the relentless pull of gravity and the march of time. And at the heart of this cosmic ballet, in the dark, chilled embrace of the Milky Way's spiral arms, new stars are born in silence. Massive clouds of molecular hydrogen, sometimes hundreds of light years wide, drift through space, cooled to just a few degrees above absolute zero. Within these frigid reservoirs, gravity slowly takes hold, causing small regions to grow denser and collapse under their own weight. As the gas falls inward, it heats, spins, and flattens, forming a protostar at the center. Over time, the pressure and temperature rise until nuclear fusion ignites, and a new star emerges from the coldest shadows, gently spun into being by the quiet force of gravity. The Milky Way's celestial canvas is not just a collection of solitary stars, but rather a tapestry woven with the threads of stellar clusters, tight-knit groups of stars born from the same collapsing gas cloud. These clusters, bound by mutual gravity, drift together for millions or even billions of years. But over time, they begin to scatter and dissolve, tidal forces from the Milky Way's immense mass, close encounters with other stars, and the internal dynamics of the clusters themselves all work to pull these stellar groups apart. One by one, the stars peel away, fading into the general star field of the galaxy. Even our own sun was likely born within such a cluster long ago, its siblings now scattered, dimmed, or lost in the hazy distance. And among the rarest and most precious objects in the Milky Way are the hypermetal poor stars, celestial relics whose atmospheres contain almost no elements heavier than helium, some with less than 100,000th the iron content of our sun. These ancient, incredibly pure stars are believed to be among the first born after the very first supernovae, carrying only faint traces of enrichment from a universe still in the process of forming itself. Scattered throughout the galactic halo like distant lanterns from the dawn of time, each hypermetal poor star is a kind of glowing, gravitationally bound signature from a near-forgotten epoch. Yet the Milky Way is not just a realm of stars. It is also teeming with planetary systems, a natural consequence of the star formation process. As a new star ignites, a rotating disk of leftover gas and dust surrounds it, and within this disk, particles stick together, gather mass, and grow into worlds. Across the galaxy, these planetary systems are a common sight, ranging from vast realms with gas giants and frozen moons to compact systems with rocky planets hugging close to dim stars. Some may resemble our own solar system, while others defy our expectations entirely. The Milky Way is not just a collection of stars, but a tapestry of solar families, each with its own unique balance, orbit, and potential. And our own home, the Earth, may occupy a particularly fortuitous position within the Milky Way, near the co-rotation radius, where the average speed of stars matches the rotation speed of the spiral arms themselves. This gentle match in motion may help shield us from frequent crossings of the spiral arms, regions with higher star density, more supernovae, and greater gravitational disturbances. In a sense, we may reside in a more stable neighborhood of the galaxy, not protected by walls, but by the resonance of our celestial motion, a quiet, shielded corner where the complexity of life has had the chance to unfold. As the sun orbits the center of the Milky Way, it doesn't follow a perfectly flat path, but rather moves in a gentle, undulating wave, drifting above and below the galactic plane like a cork bobbing on the cosmic ocean. This vertical oscillation is caused by the gravitational tug of the galaxy's immense mass, pulling and releasing the solar system as it makes its steady circuit around the center. Some researchers have even speculated that this up and down motion might influence the cycles of extinction on our own planet, though the evidence remains inconclusive. Nonetheless, it serves as a reminder that even on its unwavering journey around the galactic core, our sun is not gliding in a straight line, but rather swaying softly through the vast expanse of space. And then there is the enigmatic presence of dark matter, a substance that makes up the majority of the Milky Way's mass, yet has never been directly observed. It does not emit or absorb light, passing through ordinary matter as if it weren't there. But its gravitational effects are unmistakable, holding the galaxy together, explaining the unexpected rotation speeds of stars, and shaping the formation of large-scale cosmic structures. Without this unseen scaffolding, the Milky Way would simply fly apart. Astronomers detect dark matter not by seeing it, but by observing how it influences the motion of other celestial bodies. It is the galaxy's hidden foundation, invisible and silent, yet one of the greatest mysteries still puzzling the scientific community. In fact, most of the Milky Way's mass does not reside within the familiar luminous disk, but rather in an enormous surrounding halo of dark matter that extends far beyond the farthest stars. This unseen envelope outweighs the disk by a significant margin, sparsely populated with ancient stars and globular clusters, but with a true bulk that remains hidden from our eyes. When we gaze upon the Milky Way, we are captivated by its spiral arms and the glittering plain of stars. But this is merely the shining surface. The mass that truly defines the galaxy, its gravity, its motion, and its reach, is mostly shrouded in darkness, enveloping everything like a quiet, invisible shroud. And the heart of our galaxy may have once burned far brighter than it does today. Evidence suggests that the supermassive black hole at the Milky Way center may have once flared as a quasar, a brilliant, violent beacon fueled by infalling matter, outshining entire galaxies. If this were the case, the Milky Way would have appeared dramatically different, a spiral galaxy wrapped around a blinding core of light. That time is long since past, but the echoes of that past activity remain, hinted at by the enormous gamma-ray structures known as the Fermi bubbles and the traces of high-energy light reflected in the surrounding clouds. Indeed, the Milky Way is not a static, timeless entity, but rather a constantly evolving structure. Its spiral arm shift, bars form and dissolve, gas flows inward and outward, and stars are born and die, leaving behind a changing population. Even the shape of the galactic disk, warped, rippling, and lopsided, is slowly altering over the course of billions of years. Encounters with dwarf galaxies and the influence of dark matter can bend and twist the Milky Way silhouette, causing it to shift like a drifting cloud. The galaxy we see today is not the same as the one that came before, nor the one that will be in the future. Its beauty lies not in permanence, but in the quiet, ceaseless transformation that defines its nature. And as if this were not enough, the Milky Way is also a conduit for the faint, yet profound ripples of gravitational waves, distortions in the fabric of space-time itself, generated by the most violent events in the cosmos, from the mergers of massive objects to the collisions of entire galaxies. Though incredibly difficult to detect, observatories like LIGO and Virgo have already captured several of these elusive waves as they pass through our galactic home. And new experiments aim to uncover the background hum of gravitational waves that permeates the universe, a constant reminder that even as you rest, the cosmos is in a state of perpetual change, shifting in ways too subtle for us to perceive, yet profound enough to reveal the dynamic nature of the universe itself. The Milky Way galaxy is a tapestry of celestial wonders, where not all stars follow the expected paths. Some trace elongated, tilted orbits, looping high above and deep below the galactic plane. These stars are likely remnants of dwarf galaxies consumed by our own, or survivors of ancient gravitational upheavals. Their orbits are three-dimensional maps, revealing the Milky Way's chaotic past. By tracing their motion, astronomers piece together the invisible architecture of our galaxy's mass and memory. These stars drift like messengers from disrupted systems, tilted and stretched, yet still bound to the whole. The Milky Way is constantly emitting a flood of ghostly particles called neutrinos. Trillions of these elusive particles pass through your body every second, originating from the sun, supernovae, and cosmic ray interactions. Though the galaxy is bathed in them, neutrinos are so light and unreactive that they slip through almost everything, leaving no trace. Special observatories buried deep underground or under ice try to catch just a few flashes of light from rare collisions. These neutrinos carry information from the unseen realms of the galaxy, from stellar cores, collapsing giants, and the Milky Way's hidden energy. They are the whispers of cosmic fire. Interstellar space is not the empty void it may appear. It is a turbulent sea, where the thin clouds of gas and dust are stirred by shock waves, magnetic fields, and the motion of stars. Temperatures can fluctuate wildly, and flows of material collide, mix, and fragment. clouds stretch, fold, and tumble, creating a slow-motion turbulence akin to a swirling ocean. This restless sea shapes the formation of stars, the propagation of cosmic rays, and even the evolution of the galaxy itself. What appears from afar as calm starlight is, up close, a dynamic, rippling fabric sculpted by invisible winds and ancient energies. The galactic halo may harbor a population of rogue planets, worlds adrift in the galaxy, cold and dark, untethered to any star. Some may have formed normally and been ejected from their systems, while others may have never had a star at all. Though difficult to detect, studies suggest there could be billions of these planetary drifters in the Milky Way, some even in the sparse outer halo. Warmed only by their own internal heat, they float unseen, following lonely paths through the darkness between the stars. Interstellar dust, tiny grains of carbon and silicon, moves not only under the influence of gravity, but also under the Milky Way's magnetic fields. These invisible currents thread through the galaxy, guiding the motion of charged particles and aligning the dust. In some regions, the dust grains spin rapidly, emitting faint microwave light. In others, they align with the magnetic lines, polarizing the starlight that passes through them. Understanding these effects helps astronomers map the structure of the galaxy's magnetic fields and even remove their influence from cosmic background studies. Dust is not a passive player, but a dancer to the rhythm of magnetism, revealing hidden patterns in the dark. Some stars in the Milky Way carry the chemical fingerprints of the most violent events in the universe, the collisions of neutron stars. When these dense stellar remnants spiral together and merge, they create a kilonova, a brief but blinding explosion that forges enormous quantities of heavy elements, such as gold, platinum, and uranium. These materials are then dispersed into space, eventually mixing with gas and forming new stars. The stars that bear the imprint of these rare cataclysms are not just luminous bodies, but record keepers of ancient cosmic alchemy, burning with the residue of stellar wreckage. The Milky Way's heart is a complex, layered structure, not a simple shape. At its core lies a bar of stars, an elongated bridge of light crossing the central bulge. But deep within this primary bar, astronomers have detected hints of a smaller, independently rotating bar tilted at a different angle. This inner structure is difficult to observe directly, obscured by dust and distance, but its gravitational influence can be seen in the motion of nearby stars and gas. Bars like these may play a role in funneling material toward the supermassive black hole at the galaxy's center, feeding and shaping the dynamics of this dynamic, shifting labyrinth of light and motion. The Milky Way is not a closed, self-contained system. It draws in fresh gas from the vast cosmic web, long tenuous streams that provide the raw material for new star formation, replenishing what the galaxy loses over time. Some of these inflows arrive as cold filaments, quietly slipping into the disk, while others fall in as hotter, shock-heated streams, glowing in ultraviolet or X-ray light. These invisible rivers sustain the Milky Way's growth and evolution, linking it to the larger universe beyond. Even now, our galaxy drinks from distant reservoirs, nourished by the threads of matter spun from the early cosmos. When clusters of massive stars explode as supernovae, they create enormous cavities in the interstellar medium. These can merge into vast, hot gas bubbles that punch upward through the galactic disk, venting into the halo. The result is a kind of chimney, a channel where energy, gas, and magnetic fields escape the plane of the galaxy. These chimneys help regulate the pressure of the interstellar medium, redistribute metals, and shape the structure of the halo. In this way, the Milky Way breathes not just within its disk, but through towering columns that carry its energy up and out into the cosmic darkness. Though the Milky Way appears calm in visible light, it glows fiercely in other wavelengths, X-rays pour from its core, from collapsed stars, and from the edges of black holes. White dwarfs and neutron stars and binary systems can siphon matter from their companions, heating it to millions of degrees. Even the hot gas in the halo emits faint X-rays, revealing the galaxy's larger skeletal structure. Telescopes like Chandra and XMM Newton paint a very different portrait of the Milky Way. Not a tranquil spiral, but a realm of extreme temperatures, compact remnants, and hidden radiation. Pulsars, the rapidly spinning, highly magnetized remnants of massive stars, act as cosmic clocks throughout the Milky Way. Some rotate hundreds of times per second, pulsing in regular, measurable rhythms. Astronomers use these pulsars as timekeepers, tracking their signals to measure distances, test gravity, and even search for gravitational waves. Across the galaxy, these blinking beacons of order keep time not for minutes or days, but for entire epochs, ticking steadily in the silence between the stars. Much of the Milky Way is invisible in visible light, obscured by dust, distance, or faintness. But radio waves can slip through these barriers, revealing structures otherwise unseen. Radio observations trace cold hydrogen gas, outline magnetic fields, and highlight emissions from pulsars, supernova remnants, and distant quasars. Using arrays of radio telescopes, astronomers have mapped the spiral arms, measured the warp of the disk, and discovered star-forming regions cloaked in darkness. Where light is blocked, radio soundings allow us to see the galaxy speaking in a language we cannot hear, one that science has learned to translate into shape and shadow. The Sun was likely born as part of a stellar cluster, sharing its birthplace with hundreds or even thousands of sibling stars. Over time, the gravitational tides, passing stars, and the motion of the galaxy have scattered this once tightly bound group. Most of the Sun's siblings have wandered far, flung into different orbits, carrying fragments of our shared past. Yet some may still shine nearby, invisible among the countless stars, lost family members in a vast sea of light. Astronomers are now searching for these long-lost solar siblings, using surveys like Gaia and spectroscopic databases to identify stars that share the Sun's age, motion, and chemical fingerprint. A few promising candidates have emerged, stars that may have formed from the same enriched cloud of gas as our Sun. If found, these stellar kin could reveal valuable insights about the conditions in which the Sun and the early solar system were born. Our place in the galaxy is not as solitary as it may seem. Somewhere out there, the Sun's ancient family members may still be shining. The Milky Way's disk is not perfectly flat, but rather gently wobbles and undulates as it spins, like a spinning plate nudged off balance. This warp is most pronounced in the outer regions, where the disk bends upward on one side and downward on the other. The cause of this wavering motion may be the gravitational influence of nearby dwarf galaxies, interactions with dark matter, or internal asymmetries within the galaxy itself. The wobble rotates slowly, like a vast wave moving through the stars. From our vantage point on Earth, we don't directly feel this motion, but from afar, the Milky Way is revealed as a breathing, curving sheet of stars, not a pristine spiral. Just as the moon's gravity pulls tides on Earth, the immense mass of the Milky Way exerts tidal forces on everything within it. Star clusters, satellite galaxies, and even globular groups feel the galaxy's uneven gravitational pull, which can stretch and distort them over time. This process draws out long stellar streams or peels stars away from their orbits, unraveling these structures strand by strand over millions of years. Many of the faint arcs of stars mapped across the sky are the remnants of such encounters, where the galaxy has patiently torn apart clusters and galaxies. Measuring the mass of our own galaxy is surprisingly difficult. Stars and gas make up only a small portion of the total, with the vast majority of the Milky Way's mass residing in the unseen dark matter halo. Estimates of the galaxy's total mass vary widely, from around 1 trillion times the mass of the Sun to much higher values. This uncertainty stems from the challenge of accurately measuring the orbital speeds of stars at great distances, a task clouded by limited data and the influence of the invisible dark matter. The Milky Way, our cosmic home, remains a mystery in terms of its true weight. For many years, astronomers assumed that the Andromeda galaxy, slightly larger and brighter than the Milky Way, was also more massive. However, recent measurements suggest that the Milky Way's dark matter halo may be broader and denser than previously believed. If true, our galaxy could actually outweigh Andromeda, despite its more modest appearance. This has important implications, as the relative masses of the two galaxies will shape the dynamics when they eventually merge. The Milky Way may look gentle, but beneath its quiet spiral arms, it carries more gravitational weight than we once imagined. The Large and Small Magellanic Clouds, two bright satellite galaxies visible from the southern hemisphere, have long been thought to orbit the Milky Way. But new evidence suggests they may be newcomers captured by our galaxy only recently in cosmic terms. Their velocity and motion through space hint that this could be their first close pass, rather than long-standing companions. If true, these distant wanderers are just now falling under the Milky Way's pull, stirring the outer disk and warping the galaxy's shape. It's as if the Milky Way is responding to a new gravitational guest, with the quiet sky full of first encounters. Trailing behind the Magellanic Clouds, the two dwarf galaxies that orbit the Milky Way, is a vast ribbon of hydrogen gas known as the Magellanic Stream. This structure stretches across hundreds of thousands of light years, wrapped in sweeping curves and arcs across the southern sky. The Magellanic Stream was pulled away from the dwarf galaxies by the powerful tidal forces at play as they passed close to one another and to our own Milky Way. Invisible to the naked eye, this long, trailing whisper of motion and loss reveals itself in radio wavelengths, a ghostly testament to the dynamic interactions shaping our galactic neighborhood. The Magellanic Stream may one day feed new star formation within the Milky Way, or settle into the halo as a thread of memory stretching between these intertwined cosmic neighbors. Not everything in the Milky Way adheres to the neat, orderly plane of the galactic disk. Some clouds of gas and even individual stars move in highly inclined polar orbits, passing high above and deep below the main structure of the galaxy. These misaligned paths likely originate from past mergers, when dwarf galaxies or stray clouds were captured by the Milky Way at odd angles. Over time, they have continued to orbit on tilted trajectories, like comets circling a planet. These polar orbits serve as visible records of disruption, reminding us that the Milky Way is not a closed, static system, but an evolving structure shaped by the unpredictable flow of cosmic history. As the stars drift and the cosmic tides ebb and flow, the Milky Way continues to reveal its hidden wonders. From the tilted orbits of ancient stellar wanderers to the ghostly whispers of neutrinos streaming through the galaxy, there is always more to uncover about the dynamic, ever-changing nature of our cosmic home. Just as the Magellanic Stream stretches between galaxies, carrying the memory of past encounters, the Milky Way is a tapestry woven with the threads of disruption and evolution. Polar orbits and warped structures stand as testaments to the unpredictable currents of cosmic history that have shaped our galaxy over eons. So, as you drift off to sleep this night, remember that the universe is not a static, orderly place. It is a restless sea of motion and change, with the Milky Way itself a breathing, undulating entity responding to the gravitational dance of its celestial neighbors. The mysteries of this galactic abode are far from fully unraveled. There are always new discoveries waiting to be made by those who gaze up at the stars. Sweet dreams, and we'll see you next time on Sleepy Science, where we continue our exploration of the dynamic, ever-evolving Milky Way.